Hello, today's video is going to be on reflections. So a reflection is a transformation. It's a transformation where every point is mapped onto its image over a line. So we're going to be mapping these points. Our line of reflection could be a lot of different things. So first, let's reflect over our line x equals 1. It is important that we know what x equals 1 is. X equals 1 is going to be a vertical line. So the first thing that we're going to do is we're going to draw that vertical line at 1. When we're at that vertical line, the way that we reflect is by counting to the line of reflection. So we are going to count to the line of reflection, and then count the same amount on the other side. Count the same amount on the other side of the line of reflection. So reflections are pretty much, in this case, all about a counting game. If I want to reflect O, I count 1, 2, 3, 4. I counted 4 spots to that line of reflection, so then I count 1, 2, 3, 4, and here's the coordinate of my image. So that's the new O. G, I count 1, 2, 3, 4. So I count 1, 2, 3, 4. And there's the image of G, so I put G prime. For D, we got to count 1, 2, 3, 4, 5, 6, 7, 8. So then I count 1, 2, 3, 4, 5, 6, 7, 8. And then the image of D is over here. We make sure that we connect our points because that's what's creating the object. And we can see that this is going to be our image. Don't forget that it is important for the notation. We've got capital D, O, and G. That's the original. I know that this one is my image because of G prime, D prime, and O prime. So that's one kind of reflection. If you are reflecting over a vertical or a horizontal line, that's the way that you would do it. You would count to the line of reflection and then count the same amount on the other side. Now the next one, this is the one that generally people miss on the quiz and test. And it's not hard, we just forget how to do it. So if I want to reflect over the line y equals x, well first let's talk about what is y equals x. Y equals x is going to be a a diagonal line. It's a diagonal line with a slope of 1. So 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. It's this diagonal line that's going through. It starts at 0, 0, and it has a slope of 1. Think about y-intercept form. When I think about y-intercept form, this is y equals mx plus b. The m here is 1, slope of 1. And the b is 0. That means we have a y-intercept of 0, 0. So from here, 0, 0, we count up right 1, up 1, right 1, up 1, right 1. There's your diagonal line. Now the really easy part about this is to find your new points. All you have to do is switch your x and y coordinates. So that does require us to know the original coordinates correctly. So if I see B, B is at 6, negative 3. I go to A, I go over to A, I go right 9, down 7. t, I'm going left 1 and down 7. So those are the original coordinates of my triangle BAT. Now to find the image, we just switch where the x and the y coordinates are. So instead of 6, -3, it becomes -3, 6. I'm switching those two. This becomes -7, 9. This becomes -7, 1. So to reflect over that diagonal line, y equals x, switch the x and y. So our image of B is at -3, +6. And again, we give that with a B image. Then we have -7, 9, so we go left -7, up 9, and that gives us the image of A. And then we have t at -7, -1. That is the image of t, so t prime. And we can see that we have reflected our triangle BAT over that diagonal line y equals x. Right? And then that is it for reflections.